Hello, everybody, and welcome to Unit 3. This is the unit where we actually get into some of the chemistry. So we're done with all that introductory stuff. We're done with all that math that will be important, and actually get to talk about chemistry. Of course, we are starting at the very, very smallest and working our way up, but we are going to kind of deep dive into the atom. If you remember from earlier science classes, atoms are what makes up everything in the universe. It's the smallest piece of anything. Um, so, we're going to first talk about some history and early theories of the atom and how our modern theory kind of came into being. So, the first scientist that we want to talk about is Dalton. Dalton. So Dalton's atomic theory, and as you can see in our timeline, this is like the mid 1800s, so quite some time ago. But basically, Dalton, in his research, determined that every element is made up of very small particles called atoms that cannot be divided. So was the first tenet of his theory, which we still know today to be true. The second thing that he kind of came up with was that atoms of a given element are identical. So an atom of gold looks like every other atom of gold, no matter what. Right? And then atoms of different elements are different. He wasn't quite sure how they were different, but he knew they were different. We now know it's because of the number of protons, neutrons, and electrons that they have. But he did know that atoms of like hydrogen and atoms of aluminum are different from each other. The third part of his atomic theory is that chemical compounds are formed when atoms of different elements combine. And he also knew that a given compound always has the same relative numbers and types of atoms. So, water, which is a chemical compound, always has two hydrogens, one oxygen, never anything different. That's always what water is composed of, no matter what, no matter where. Two hydrogens, one oxygen. And lastly, he also knew that chemical reactions involve the reorganization of atoms. Reorganization doesn't quite fit in that little space. So a chemical reaction is basically reorganizing those atoms. I like to think of it like Legos. You can buy those Lego kits that are like, these 50 Legos will make a truck or a fire engine or a house and it depends on how you put them together, right? Well, the same is true with the elements. When we have only 118 or so elements and put them together in different ways, and they make everything in the universe. They just get reorganized into different patterns. And the last part of this is that the atoms are not changed in those chemical reactions, right? Again, just like with the Legos, you don't cut a Lego in half to make it change from a truck to a fire truck to a house. The Legos don't change; they just get reorganized into different patterns, right? So Dalton was first. Then came a man named J.J. Thomson in the late 1800s, early 1900s. Thompson. And he studied what were called cathode ray tubes and the electricity that went through them. You'll actually watch a video about this as part of your work for this section. It's pretty interesting. So J.J. Thomson discovered these negatively charged particles, and he called them electrons. So we do know still that electrons are negatively charged. His theory was that there was a cloud of positive charges with negative charges floating inside of it. So you can see in his picture of the atom, this gray is with the pluses is the positive charge, and then randomly scattered throughout the dark spots are the negatively charged electrons. This model was actually called the plum pudding model. We don't eat a lot of plum pudding, but it's kind of like a chocolate chip cookie. not plum pudding, but the model of the electron. Um, so, but the electrons are kind of like plums in a pudding or chocolate chips in a cookie, right? They're just randomly scattered throughout this cloud. So that was J.J. Thomson. Um, we are moving on now to someone named Robert Millikan. Robert Millikan did this oil drop experiment. Again, fairly interesting. You're going to watch a video that demonstrates it as part of your work. But through this, he was able to calculate the mass of an electron, which you can see if you go back up top here, is 9.11 times 10 to the negative 31 kilograms. So that's a whole lot of zeros and a really tiny number. Electrons don't weigh very much at all. Okay. So then, moving on to kind of the early 1900s still, but someone named Henry Becquerel, Henri, actually, he was French. Oops, I'm going to spell it. Oh, no, that's right. BEQ. Y'all, I'm all messed up right here. I shouldn't look at my paper. I should just know how to spell it. BECQUEREL. Henry Becquerel, again, French guy. He discovered radioactivity while studying uranium. We know Madame Marie Curie did a lot of work with radioactivity as well. But in moving forward with that, scientists discovered that there were 3 types of radioactivity. There were alpha particles, beta particles, and gamma particles. You've probably heard of gamma radiation. You might have heard of the others. But alpha particles, always abbreviated with the Greek letter A, alpha, had a charge of +2 and a mass of 7,300 times an electron. Right? Beta particles are just highly charged electrons. And then gamma particles are those high energy light rays that we hear of pretty frequently. Right? And I think this sentence is kind of important, but it says each of these discoveries help scientists get closer to what we now know the atom looks like. So that's just a brief history. Again, you're going to be watching some other videos with demonstrations of a lot of the experiments that led to these studies.